All right. Now, the ideal gas law you are given on your reference sheet. And so let's, first of all, see how we can use that to guide our thinking. I mean, I guess you guys get a little note card, right? So you could put all the other gas laws on there if you'd like. But anyway, so if you need more on there and you want to save room, I'll give you a little hint here. All right, so the ideal gas law. And what do we mean when we say ideal? So everything goes perfectly, right? And in the real world, okay. But again, so why do we use this? It's to make predictions, yeah? That's what we do in science. Okay, so we use mathematics to help us to make predictions. And this is our best efforts to do that, okay? So the ideal gas law is PV equals nRT. You may have heard of Pervner, I don't know, but whatever, okay? You don't have to memorize that because it's on your reference sheet. So what does P stand for? Pressure, V, volume, T, temperature. And then we got a couple others. Did we talk about what N means? So let's write these real quick. So this is pressure. This is volume. And this is temperature, like we learned last time. Or everybody that was here last time. I know it was Halloween. Okay. But was Yale able to get that video? Okay. So anyway, N represents the number of moles. Okay? And R is the ideal gas law constant. Okay? And it depends on a few things, so we'll just say gas constant. So if we use specific units, we can use this constant. This constant will work. But if we have different units, it's a different number, okay? So before we get into that heavily, if we deal with a certain condition, we're going to have a certain number of moles, right? So that's pretty much constant, and that's pretty much constant. So if that's constant, then, and it's not always going to be constant, but in certain conditions it is. So if the number of moles is constant, and of course this R is a constant value, then we can figure out what that constant is equal to, just like last time, right? So we divide both sides by temperature, and we get PV over T equals our constant. Are you with me? You understand how I got that? Divide both sides by temperature, and then I get this, right? Well, if this is a constant, then we got PV over T equals PV over T. Well, sure, but we can put a 1 right here and a 2 right here. And this is our combined gas law that we learned from last time, right? There we go. What if our temperature is constant? Then we have Boyle's law, and so on. So all of our equations are hidden within there if you want to use your little note card for other things, right? If you don't have anything else to put on your note card, okay, I guess put all those equations on there, right? So do whatever you need to do. But I just thought I'd bring that out and maybe it would help somebody. If not, I'll just throw it out the window. Good? All right. So if we do the same thing, so now we're here. Let's divide both sides by N, the number of moles, and we're going to get R is equal to PV over NT. You follow? And so the units that we use, in fact, the value for this is 0.0821, good. But it's only that number if we use the following units. Pressure needs to be ATM, volume needs to be liters, and of course, number of moles is moles, and temperature needs to be measured in Kelvin. If we're using those units, that's our R value. Good? And do you have to memorize that? No, it's also on a reference sheet. So are the units. So just make sure you have those units. Double check that reference sheet, make sure you look at it, you get it, so you just as well use it. Okay? Any questions so far? All right, let's do an example using this, because this is just a formula. If we know some values, we can plug them in and solve for anything, right? It's really just a plug and chug, or just a simple calculation, as long as we follow order of operation, but we just have multiply and divide, so it really doesn't matter, does it? Okay? So let's do an example. Let's say we have 3.5 moles of oxygen gas, and we have a volume of 27.0 liters at a pressure of 1.6 ATM. We want to know what the temperature is. Okay. So we can say this is our number of moles, this is our volume, this is our pressure, and we want to know temperature. Are we good? And of course, I will be giving you words with this, right? So are you guys comfortable picking your stuff out? What is the volume, what's the pressure, what's all that stuff, okay? So write down what you know, what you're looking for. Find an equation that uses all that stuff. In this case, PV equals nRT. We know the pressure, we know the volume, we know the number of moles. We even know our constants, so we can solve for T. So we decided we like to solve before we put the numbers in. How you guys feeling? Who wants to do it the other way?
Before.
Okay, so we divide both sides because it says multiply, right? By N and R, those cancel, we do it to both sides. And we got our temperature is equal to PV over NR. All right. So let's see. Our pressure is 1.6 ATM. Our volume is 27 liters. And our number of moles is 3.5 moles. And then our R constant is 0.0821 ATM liters per mole Kelvin. Actually write that. You don't have to memorize it. It's on your reference sheet. And let's see what cancels. ATM cancels. Moles cancel because this is on the denominator, this is a numerator, all on the denominator. You following? And liters. And then we have per Kelvin on the bottom, so that flips it up. Multiplied by the reciprocal, right? And we got, so yeah, we should get Kelvin. But if we're using the same units, guys, temperature is measured in Kelvin, so it's going to be in Kelvin. If it's number of moles, it's going to be moles. If it's whatever it is, that's what it is. Okay? So we multiply and divide all that, and we get our temperature of 150.3 Kelvin. And if it asks for the temperature in degrees Celsius, then we just convert that to degrees Celsius. Simple enough? When I say simple, it's Maybe we think of math as yuck, 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 but that's all it is. Questions, yeah?
So you said the 0.0821 is given to us on our reference sheet?
Yep, it's on our reference sheet, right there. And even the units are there.
Thank you.
Yep. So a lot of times we want to just do it without looking at anything because it's faster. What are we in such a hurry for? Just use it, look at it. Double check, make sure we don't make those silly mistakes that we always make on exams, right? Okay, I mean, I've done it. We all do it. So just slow down, use what we're given, use our resources, and you have that little card. Make sure you have studied well enough, you know it needs to go on that card. Okay, are we good? Oh, let's see, what do we want to do another one? Okay, let's do it.
If we need to find n, is it just the mass over the molar mass?
If we need to find n, then that's the number of moles.
Yeah, so that's just like the mass of whatever compound?
No, that's just moles.
Just moles?
It's just moles. If we need if we're looking for the number of moles, we calculate for n. We solve for n. Did I answer your question, or did I not understand what you're asking?
No, that's good.
Okay, so we only use molar mass if it's asking for number of grams. Yeah, we find n, solve for the number of moles, and then we use the molar mass to convert it to grams.
Okay.
So yeah, that's definitely a possibility, right? Maybe you're looking for grams, and there's no grams in this formula, so that's how we'd do it. Convert everything to moles, and then we can use the mole road map that's also on here, convert it to grams or whatever. Good? Okay? Good question. All right, let's go see. Let's say we have a volume of 500 milliliters, and it can hold a pressure of 15 atm. We want to know how much gas can be carried at room temperature. At a temperature, so room temperature, you guys know what room temperature is? 70 degrees Fahrenheit, right? Eesh. So what is that? 25 degrees Celsius? Okay. And you'll be given that. You don't have to memorize that, okay? All right, so now what? We want to know how much gas we have. So what are we looking for?
Looking for the moles of gas?
Moles, that's the only thing that is the amount of gas that we don't already have, right? We have a volume, we have a pressure, we have temperature, so the only thing missing is number of moles, okay? And if it was asking for how many grams, then we'd convert moles to grams, right? So we're going to use PV equals nRT, and we're going to solve for number of moles. How do we do that?
Divide by RT on both sides.
Divide RT to both sides, good. And we got the number of moles is equal to our P, which is 15 atm, times our V, which is 500 milliliters, divided by R, which is 0.0821.
Do we have to convert?
And then multiply by 25 degrees Celsius. Are we good?
don't we need to convert from milliliters to liters?
Yeah, ladies and gents, I just did this on purpose. Now, if we, let's say we don't even put the units in. We just forget about the units and just put our numbers in and plug and chug. How many times do we do that? We're gonna be off the board here if we do that. It's like, well, I used the equation, how come I got it wrong? You've got to be in the right units. So ATM, that is a unit that we need. We gotta change 500 milliliters to liters. So what is that? 0.5 liters. Do you have to do that in your head? No, please don't. So 500 milliliters. We know that 1,000 milliliters is the same as 1 liter, right? 500 divided by 1,000 is 0.5. Good. And then we got to change 25 degrees Celsius to Kelvin. 298 Kelvin, 298.15 if we're specific here. And again, that's just Kelvin equals degrees Celsius plus 273.15, right? And again, that's on our reference sheet. Questions so far? But again, I didn't write the units here, but I always do just to make sure, because especially since I have it right here. Copy what the units are, and then just make sure everything cancels. So I'm going to rewrite this. N is equal to 15 ATM multiply 0.5 liters all over 0.0821 ATM liters per mole Kelvin multiply 298.15 Kelvin. ATM cancels with that ATM, liters cancels with that liter, Kelvin with that Kelvin, we're left with moles. Everything's great. Do that, we get 0.306 moles of
Whatever gas.
whatever we're dealing with, right? Are we good? Questions? So everybody feels 100% confident with that? So you could be asked a lot of different questions using this formula. You could be given different units, so just make sure you're in the right unit and you solve the unknown variable. That's it. All right, let's do, that's like a problem you might see in a math class, right? Doing math class, you do all of this equation over and over and over again until you're sick of doing it, right? Now let's do a real problem, shall we? Where we have to apply everything that we've learned so far. Can we do this? Do you remember stoichiometry? Dimensional analysis? Okay? Still got to know this. So let's do a problem here. So we have a reaction. Sodium as a solid plus H2O as a liquid gives us sodium hydroxide aqueous solution plus hydrogen gas. So there's our chemical equation. Sorry, I always go at an angle. You guys hate that? Sorry about that. Just write it straight. Okay. And let's say we have 3.4 grams of solid sodium. They're reacting in water with enough water to completely react. How many liters of hydrogen gas will be collected at a temperature of 25.3 degrees Celsius and a pressure of 1.05 ATM? Yeah, question.
Do we need to balance the equation first?
That's a great question. Do we need to balance the equation first? Yes. If we don't have a balanced equation, we're just dealing with the ingredient list. We need a recipe. Yeah, we must. That is the first step of stoichiometry, right? And you got to know that. In my notes, it's balanced. It comes balanced, but I say, let's do it without balance. Make sure we remember that step. Exactly. Perfect. So if we balance this, what do we do?
You could put
Let's
in front of the sodium.
in front of the what?
The sodium hydroxide,
2 right there because
because then that would make it,
we have an odd number right there, even number right here, even number right there, yeah?
yeah.
Okay, perfect. So that gives us 4 hydrogens on the right. Does anybody need me to show my work on balancing? Good. So that means we need a 2 right there to make 4 hydrogens on the left. But since we put a 2 right there, there's 2 sodiums, so we better put a 2 right there. There's 2 oxygens, 2 oxygens. Okay, we're good. Good? All right. So that's balanced. Now what? Start with something we know. Oh, we know a lot of stuff. Which one are we going to start with? Does it matter this time? It sure does. If we start with temperature, are we going to be able to convert temperature to liters?
No.
No, temperature's nothing to do with the matter, right? And pressure, not really either. So, do you understand that? So, we have to start with 3.4 grams. Make sense? 3.4 grams of sodium. Write everything out. Now what? What are we going to convert that to? What, in fact, let's think about this. Is there an equation with all this stuff in it? We got pressure, temperature, and we're looking for volume. We have an equation with all that stuff in it? Yeah. PV equals nRT. We're looking for this. We're looking for volume. We know the pressure. We know the temperature. We know R. We don't know N. So we got to find number of moles of what?
Hydrogen gas.
Of the hydrogen gas. It's got to be a gas. But we want to know volume of gas, right? Volume of hydrogen gas. So we better find the moles of that gas. It doesn't make sense to find moles of a different substance if we want to find the liters of of a different substance, right? Got to be the same substance. Does that make sense, or did I say too many words? Okay. So we need to find moles of hydrogen. I'm going to erase this, get that out of the way, because it's right in my way here. So I got to convert grams of sodium to what? Look at our mole roadmap, and what does it say?
So moles of sodium.
Yeah, we got to go to moles. It's the only thing we can do. Using the molar mass of sodium, which is 23 grams of sodium. And again, don't memorize this, guys. Did I get it right?
22.99.
Yeah. In fact, did you notice on the test? Did they round? No, they did they? It don't.
Oh, shoot, never mind. I just spit it out, sorry.
Okay. No.
I think so.
It seems like we didn't round, but again, I'm not gonna say, I got you. You didn't round. I'm not gonna do that. But so we can not round. That's okay. So 22.99 grams of sodium to 1 mole of sodium. We're still looking for liters. Actually, in the end, we're looking for moles, right? Before we can use that equation. Okay. do you understand how do we know what to do? Anybody still have a question? Okay. So you kind of look with, first of all, you have to know what you're looking for and you have to know what you know. And from there, you can kind of make a plan of action. All right. So now what are we going to convert to? Moles of sodium to what?
Moles of hydrogen.
Moles of the substance we're looking for, hydrogen, yeah. So what's the ratio? 2 to 1. 2 moles of sodium. Any questions on that? Just using the coefficients in our balanced equation. Moles of sodium go away. So we keep going. We're not there yet. But we are there, right? We are. We're at moles of hydrogen. That's what we're looking for. So that we can use that equation, that formula. So we multiply, or 3.4 divided 22.99 divided by 2, and we get 0.0739 moles of hydrogen. But that's not our answer. We're not done. Are we good so far? Now we got a PV equals nRT. And we're looking for volume, so let's divide both sides by pressure, which is equal to the number of moles, 0.0739 moles. Are you with me, or am I going too quickly? Multiply R, which is 0.0821. ATM, liters per mole Kelvin. Always look at the reference sheet, guys. I almost flipped it. Stuff happens, right? Don't try to memorize that. You don't have to. And then multiply by temperature. Needs to be measured in Kelvin.
298.45.
298.45. Thank you. All over the pressure, which is already an ATM, so we're good. Let's see what cancels. Whoops. ATM cancels. Moles cancel. Kelvin cancels. All we're left is liters. Good, that's what we're looking for. And we get our volume is equal to 1.72 liters. Does that make sense? So, quite a few steps to get there, but it's everything we've learned. Well, from last unit, right? In this unit. Okay. Questions? All right, we got one more idea for the rest of this chapter. And then, depending on how you guys are feeling, we can start on the next chapter. But we'll see when we get there, okay? Questions so far? So on our worksheet, we have the back page, section 4. You want to try one of those? Yeah, you need one? Yeah, does anybody else need one? No. Yeah. Sorry. I should have put these over there because, yeah, a lot of us wasn't here last time.
Thank you.
Anybody else need one? No, why don't you try one of those? So the first one is just using the ideal gas law. But if you really want to test yourself, start on where it says aluminum sulfide reacts, and that one right there. We have an equation. Do that one or the next one. I mean, you can try the first one too, that's fine. We still need to know how to use the ideal gas law. How do I feel? Hang on. How we coming? Do we want answers or? Okay. 20 to zoom in on one. Questions? Do you want to do one together? You want me to zoom in on one? Can you see it?
I don't have my other papers with me. Can you go over how to switch from Celsius to Kelvin again?
Yeah.
Just so I can write it down.
Yep. So it is on our reference sheet that we get on the exam. But Kelvin is equal to temperature in degrees Celsius plus 273.15. Good?
Yeah.
Anything else? Nothing? We're ready to move on? Okay, we're here for you, just so you know. If you have a question, just please let me know. All right, let's talk about partial pressures, mixtures of gases. So a lot of times, we don't just have one gas. Like the air that we breathe has multiple gases. Okay? So let's think about the amount of gas versus the pressure of gas. How is it related? As we increase the number of moles, the pressure is going to increase. Does that make sense in everybody's mind? If you have a container, a fixed volume, if we increase the amount of gas in there, that means it's going to be higher pressure, yeah? Okay, so they're directly related. And we can say that the total pressure of our gas, of our mixture of gases, is proportional to the total number of moles. And we can also say that the partial pressure, or that's the pressure of one of the gases, is proportional to the number of moles of that gas. I'm using A as a general variable. Are you okay with that? We'll do examples where we talk about different gases, but does that make sense? All right, let's also, so let's say we have air. Okay? Do you guys know what air is made of? What kind of gases do we have in air?
Nitrogen?
Yeah, mostly nitrogen. We have carbon dioxide.
Oxygen?
Hopefully we have oxygen, right?
Hydrogen?
And we might have a little bit of water, which has hydrogen in it. And we might have argon or whatever, right? but we'll keep it simple. And say we have 3. How's that? Because those are probably the most abundant, okay? Not a ton of carbon dioxide, but okay. So if we have, let's see, let's just say total pressure is going to equal the pressure of nitrogen plus the pressure of carbon dioxide plus the pressure of oxygen. Do you get that? So we say each of these, this is the partial pressure. Of each of those gases, as that's just part of the total. Are we good? Okay. And we can also say N total is equal to the number of moles of nitrogen plus the number of moles of carbon dioxide plus the number of moles of oxygen gas. Does that make sense? Okay. So if these are true, this is the proportionality, we can change this to an equation and we'll write it like this. Let's do PA. Example, that could be like pressure of oxygen, right? Or pressure of nitrogen. Just one of the gases. The pressure of one of the gases over the total pressure is equal to the number of moles of that gas over the total number of moles. Let's know that. And that is not on your reference sheet. So let's put that on our card, okay? And then it's just a formula.
Sorry, can you say what that formula is one more time?
This is the partial pressure formula. We use for when we have a mixture of gases.
And what does the A stand for, sorry?
So the A is just one of the gases.
Okay.
So we can say this. So I wrote this example for air, but we can say partial or the total pressure of all of our gas is the partial pressure of A plus the partial pressure of B plus the partial pressure of C plus however many gases we have, right? Where A, B, and C is just a different gas. And then N total is equal to the number of moles of A plus the number of moles of B plus the number of moles of C plus however many we have. Does that make sense?
Yes.
And so we can also say from here that the partial pressure of B over the total pressure is equal to the number of moles of B over the total number of moles.
So it stays the same with whichever gas you have.
Yeah. Uh-huh. So notice this is the same gas, and this is the same gas. And that has to be that way. Good? So let's do the last one on our worksheet. I need to get more examples in my notes because I don't have very many. So let's just do this section, part 5 together. Says a mixture of gases contains 1.25 moles of nitrogen gas, 2.05 moles of hydrogen gas, and 3.63 moles of ammonia gas. If the total pressure is 2.35 atm, what is the partial pressure of each component? So partial pressure of N2, partial pressure of H2, partial pressure of NH3. So that's what we're looking for. So what can we do first? We're going to be using this equation, right? So we're looking for the partial pressure of a specific gas. We have to know the number of moles of that gas, and we do. We have to know the total pressure, and we do. And we have to know the total number of moles. Do we know that? We don't. Can we figure it out? How do we do that? We add all of these together. That's it. You with me? Okay. So it's 1.25 plus 2.05 plus 3.63, and our total number of moles is 6.93 moles. So now we know that. So should we just plug these in each time to the same equation and then do the math? Or should we solve for the partial pressure? And this is where it's beneficial to solve before you plug the numbers in, guys. So we know our equation is P A over P total equals NA over N total, right? So let's solve for this, because that's what we're looking for, yeah? The partial pressure of each one. So let's multiply both sides by total pressure. You following me? And I have the partial pressure of whatever gas I'm looking for is equal to the number of moles of that gas times the total pressure divided by the total number of moles. And now it's set up for all three of these. Are we good? Any questions so far? All right, so let's plug our values in. So we can say, let's find this one first. Partial pressure of nitrogen gas is equal to the number of moles of nitrogen gas, and rather that, let's just plug in the value here, 1.25, because I'm just using this equation, 1.25 moles of nitrogen gas multiply the total pressure, which is 2.35 ATM, divided by the total number of moles, which we calculated to be 6.93 moles. And moles goes away, and we're left with ATM. And that gives us 0.424 ATM of nitrogen. You follow? Now we're just going to use this same equation 2 more times to find these two. Go ahead. Or is it too messy up there? Any questions? Uh-oh. How'd that happen? Now you guys are on your own for real. Oh, okay. I don't know what happened. Sometimes it does that.
I think you can shake the iPad. Like seriously, you can recalibrate it. Yeah. Up at the top where you're shaking it. It's like if you shake it like this. No, not an actual shake.
You
Like
invert
this.
it?
Yeah, like you invert it a little bit. That happens to me after everything on my notes. Nothing.
It's just the zoom.
I'm not even trying like for real.
Have you tried
Usually
turning it on and off?
Then I'll lose everything.
There's not
Don't
an
tell me.
undo button?
What?
There's not an undo button? It's usually right by your pencils.
Yeah, I did undo, but.
It's not undoing.
Oh, there it is. Oh. Oh, I'm not dumb. Oh, gosh. How did, okay, whatever. Thank you. I appreciate that. Technology savvy people. Oh, gosh. All right, so did we get our answers yet? Partial pressure of hydrogen gas should be 0.695 ATM. Whoops, ATM. And the partial pressure of ammonia, NH3, is 1.23 ATM. Are we good? So, this first chapter is basically equations, formulas. Not too bad or too bad? What are you thinking?
Not too bad.
Because we're all different. Some of us think, ew, yuck, right? But, questions? All right. Do you want to save the rest for next time? Or we got 2 more times before the exam. And we got 2 more lessons. I could save the rest or we can keep going. What do you think?
Is it on Tuesday or Thursday?
It's on, it's on,
It's on Monday.
it's on Thursday.
It's on Thursday?
So we have,
This is on Tuesday.
well, let's see.
Yeah, it says Monday or Tuesday.
Yeah. Ladies and gentlemen, I think it says our testing day is always on the wrong day,
Yeah.
okay? Do you want me to, do you want,
Thursday.
maybe I should send you this.
Yes,
Yeah.
Would that be useful?
yes.
I don't know why I haven't been sending that. Okay. I will send you that.
So it is on Thursday.
Yeah, it's on Thursday the 14th.
Okay,
I
next
thought it was
Thursday.
Tuesday.
So
It's not on
Not this Tuesday.
not this Thursday, but the following.
Tuesday, take it Thursday.
Yep. So we have 2 more after tonight.
Well, the more we get to tonight, the more time we have for review.
Okay. Last time, listen.
You don't have nothing to do.
No, I'm gonna just tell you what happened last time, and I'll let you guys make the choice. Okay. Last time, no one had any questions. They just wanted to scooch out early. And I'm okay with that. I'm just saying, if we're gonna do that again, let's just keep it simple the whole time and just do 1 lesson tonight, then do 1 lesson next time and 1 lesson. But if you guys want to cram it through so we can review, your call. Your call.
I leave it up to popular vote.
Should we vote?
Yeah.
Okay, we're done with the chapter. I mean, it is election night, right? We gotta go home and, we don't know if we're gonna party yet, right? Okay. So, who wants to stay? Because they just want, give me some more chemistry. Come on, anybody? Who wants to go home? Because we don't want to get too. That's 3 against 3. Oh, there's the 4th one. Uh-oh. Okay. If you want to stay, I got to stay for another hour before my next class anyway, so it's not helping me at all. So whatever you guys want. Okay. If you have any questions, if you want to stay and ask questions, you can. I'm here anyway.
Outnumbered.
Barely.
Most of them didn't care. I was like,
I have to go to lab after this anyway, so I'm either hanging out or I'm here.
Lab?
Same. Yeah,
I don't care.
us 3 have
Okay.
lab
I have
right
so
after
much
this.
respect for you.
all right, well, we can study. We can practice this stuff, right? I'm not saying we together. I mean, we can. I don't care. I'm here anyway. So there you go. That works too. But yeah, we're done. Have a great night. Enjoy yourself. And don't wait too long to get that reference card made. Get it made and start using it. Have a fantastic night. Thank you.
Last class we have, that Thanksgiving week, I think we have a class on Tuesday. I won't be here on that Tuesday, so a heads up.
Hey,
You live out too?
I don't want to be here either.
I feel like you might be the only one here.
Well, that's how it was on Halloween. It's like, hold on, ladies and gentlemen, can I ask you something?
Yes.
How was the Tuesday before Thanksgiving? Because on Halloween I had like 5 people show up. It's like,
You had a big wolf.
so here's what we can do. If no one's going to be here, I can make a video of the lesson and then send it to you. And if you want to be here, I will be here. All right? But I just feel like no one probably wanted to come on Halloween anyway. Who came on Halloween? Okay. So a lot of this
If
class,
you're
but
gonna be,
okay.
you're gonna be here still, or you're gonna like be home?
Oh, no. If no one's going to be here, I'm not going to be here either.
I know.
But
I think you can make a video and send it instead of us showing up.
For what day?
for the Tuesday before Thanksgiving.
Do you want us to say no?
But just wait, just, you don't have to say no, but you can say
No to what? I mean, what do you ask?
yes. You can say yes.
What if we do a
Yeah,
video of
yes,
the
you should
lecture?
come. Is that what you...
Yes, yes.
What was that?
What if we do a video of the lecture, but if we come to class, then we do like a review?
Okay, we can do that. Let's see. So
Wait, do we have an exam?
the exam is the next week on Thursday, so it's
Oh.
no. I could be here. I'm just asking. That's it. I'll be here.
I don't know. I mean, because I have lab before, so I have to come.
Okay.
I'm just saying.
All right. Yeah, I'll be here.
I can't, like, I'm not gonna miss the lab to do a makeup lab a week ago.
Yeah, no, yep, I get it. Okay, I'll be here. We'll plan on class.
But you can say yes. You can say yes.
Oh, so it would be reviewed for the class.
No, we have thanks for the lesson today.
Thank you. Thanks for coming.
Should we bring Thanksgiving dinner?
No, I'm not going to be here on Thursday. Just kidding.
Early Thanksgiving dinner.
Is the fifth exam our final, or is there a final after the fifth?
There's the final after the 5th.
Oh, also, you don't have to do the final, right? If you
Yep.
have a good grade.
So we
Oh, yeah, that's right. Uh-huh.
one on Thursday.
This
Yep.
one gets dropped either way.
If you're happy with your grade after exam 5, you're done.
It doesn't affect it?
Well, I drop your lowest score. So if you don't take it, that is your lowest score.
I didn't think it like that.
Good?
That makes sense, okay.
Okay. Thank you. Take care. Drive safe.